Welcome to BSS Studies. I am Bala. Today I will explain about mole. So here what is mole? Before going to mole, we have to know about one of the things. Avogadro number. Avogadro number. So here what is Avogadro number? Avogadro number is 6.023 into 10 power 23. 6.023 into 10 power 23. It is a Avogadro number. Basing on this number, mole is defined as Avogadro number of particles. Avogadro number of particles is known as mole. Okay, Avogadro number of particles is known as mole, which means, for example, I am taking oxygen atom. Oxygen atom weight is 16. Atomic weight of oxygen is 16. Here I gave one of the oxygen atom. I am asking to find how many oxygen atoms in this oxygen. Okay, in this oxygen how many atoms are there? So if we see here, the oxygen molecule is O2. Here there are 2 atoms are there. How we will write? 2 into 6.023 into 10 power 23 atoms. Okay, we have to multiply Avogadro number. Here one of the important point is Avogadro number is written as Na or M dot or L dot. Okay, mostly Na. So here we can write this as simply 2Na, 2 into Na. I will explain again. See, here the oxygen molecule is O2. Here in this there are 2 atoms. So I am asking to find how many atoms are there. So here we have to write as 2Na. 2Na means 2 into 6.023 into 10 power 23 atoms. Okay. Another example. Nitrogen. Nitrogen molecule is N2. Okay. Here I am asking to find how many atoms are there. How many atoms are there? How many electrons are there? How many protons are there? How many neutrons are there? Okay, I have to find these how many atoms, how many electrons, how many protons, how many neutrons. If we see here, there are 2 atoms. Here we can write as 2 into Na, 2 Avogadro number of atoms. Here how many electrons means, in one nitrogen there are 7 electrons. And in 2 nitrogens, 14 electrons. Okay, here in 1 nitrogen there are 7 electrons and in 2 nitrogens there are 14 electrons. Okay, so here we can write as 14 into Na, 14 Avogadro number of electrons. And here 14 into Na. because electrons and protons are equal number. So here we can write as 14 Avogadro number of protons. Okay. And here neutrons. Neutrons means mass number minus atomic number. Okay. Here the mass number of nitrogen is 14 minus atomic number 7. The remaining is 7. So the remaining 7 means here neutrons are there. 7 neutrons are there. Okay. So I am rubbing this part. So 7 neutrons are there means in 2 nitrogens 14 neutrons are there. See here, in 1 nitrogen 7 neutrons are there and in 2 nitrogens 14 neutrons are there. Okay. So here we can write as 14 into Na. Okay. And here another question I am asking to find molecules. Molecules. Here molecules means here N2 is a molecular form, diatomic form. So when we combine two atoms, two nitrogen atoms, it forms a one molecule. So here N2 means one molecule. One molecule means 1 into Na molecules. Okay, 1 into Avogadro number of molecules. Okay, I will explain again. Here in N2, nitrogen means N2. Okay, there are 2 atoms. 2 atoms we can write as 2 into Avogadro number of atoms, and electrons means in 1 nitrogen there are 7 electrons. In 1 nitrogen 7 electrons and in 2 nitrogens 14 electrons. So 14 into Avogadro number of electrons, and electrons and protons are equal. So we can write as it is also 14 into Avogadro number of protons. And here neutrons means mass number minus atomic number, which means 14 minus 7. The mass number of nitrogen is 14, atomic number 7. So if we subtract 7, in 1 nitrogen 7 neutrons are there, and in 2 atoms, in 2 atoms 14 neutrons. So we can write as 14 into Avogadro number of neutrons. And in molecules, molecule means when we combine 2 nitrogens, it forms 1 molecule. So 1 into Na molecules, 1 into Avogadro number of molecules. Okay. And another example. NO2. NO2. NO2 means it is a compound which has 1 nitrogen and 2 oxygens. And it has nitrogen weight is 14 plus oxygen weight is, here O2 is there. O2 means 16 by 16, 32. So here 14 plus 32, 46. So here in this compound 46 grams is weight. Okay, 46 grams is the weight of this molecule or compound. So if you see here 1 into 6.023 into 10 power 23 nitrogen atoms, and 2 into 6.023 into 10 power 23 oxygen atoms, because there are 2 oxygen atoms, here 1 nitrogen atom, so 1 into Na nitrogen atoms and 2 into Na oxygen atoms. Okay, and another half into Na molecules of nitrogen, 1 into Na molecules of oxygen. Here see, here nitrogen molecule form is N2 and oxygen is O2. So here, if you see here only 1 nitrogen is there, 2 nitrogens are there means 1 molecule, and here 1 nitrogen means half molecule, half Na molecules of Na, and here O2 is there, O2 means 1 molecule, so 1 into Na molecules of oxygen. Okay, so like this we can write with Avogadro number. And here another, see, STP conditions. STP conditions. STP conditions means when temperature, we have to know about temperature at STP conditions means standard temperature pressure. Okay, so here temperature is 0 degrees and 273 Kelvin. This is STP condition of temperature. And pressure. Pressure is 1 atm, 1 atmospheric pressure. And here volume. Volume is 22.4 liters. Okay, and here another important point, half of the volume means 112 liters. Okay, no need of this half volume. So these are the STP conditions. Temperature means 0 degrees 273 Kelvin. Pressure means 1 atm. Volume means 22.4 liters. Okay. Or here 1 bar or 76 centimeter of Hg or 760 millimeters of Hg. Okay. So these are the STP conditions. And the problems. Here in the first one, the weight of 1 mole of sulfur. Here the weight of 1 mole of sulfur means, here 1 mole of sulfur is equals to S8. The 1 mole of sulfur is S8. It is in the polyatomic form. Okay, polyatomic form, S8. So we have to find the weight of 1 mole of sulfur. Weight. We have to find weight, which means only 1 sulfur 32 grams, and we have to multiply with 8 because we have to find 8 sulfurs. So 32 into 8, 256 grams. Okay, I will explain again. We have to find the weight of 1 mole of sulfur. In 1 mole of sulfur, the atomic form of sulfur is S8. Okay, so we have to find the sulfur atoms 8 sulfur atom weight we have to find. So here weight is equals to 32 into 8 because 32 grams. 1 sulfur is equals to 32 grams and we have to multiply with 8 because 8 sulfurs are there. So 32 into 8, 256 grams. Okay. So this is first sum. And second sum. How many moles contain 1.5 grams of acetic acid? Here acetic acid means CH3COOH. Okay. And we have to find out how many moles containing 1.5 grams of acetic acid. In 1 mole of acetic acid, 1 mole of acetic acid contains 60 grams. How many moles does acetic acid contains? I will write again, see. Here 60 grams present in 1 mole. And here we have to find 1.5 grams of acetic acid. Okay. So here cross multiplication. And here 1.5 into 1 mole means Na by 60. Okay. So 60 into 10. I am removing this point. So 15 ones are, 15 fours are. And here Na by 40. I will explain again. See. $60 grams present in 1 mole. 1 mole means Na. Okay. And here 1.5 grams contain how many moles? Here cross multiplication. So 1.5 grams into Na by 60 grams. Here I am multiplying 60 into 10 by removing this point. Okay. So 15 ones are, 15 fours are. And here Na by 4 into 10, 40. So this is the answer. Na by 40. Okay. So this is second sum. Third sum. Weight of 1/4 mole of calcium atom. Weight of 1/4 mole of calcium. In 1 mole of calcium, 40 grams will be present. And in 1/4, we have to multiply with 40. So 4 ones are, 4 tens are. So 10 grams is the answer. How? In 1 mole, 40 grams. And in 1/4 mole, how much? Cross multiplication. So here 1/4 into 40, which is nothing but 10. So 10 grams is the answer. Okay. So this is third sum. And fourth sum. Number of electrons present in hydrogen. Here they ask you to find number of electrons present in hydrogen. In hydrogen, in one hydrogen, 1 electron will present. Here we have to take hydrogen means we have to take H2 because they did not mention hydrogen atom or hydrogen molecule. So most of the we have to take H2 only. So here 2 hydrogens means 2 electrons. So we have to find number of electrons, which means 2 into 6.023 into 10 power 23 electrons. Okay. So this is fourth sum. And the fifth sum. The number of molecules present in 8.96 liters of a gas at 0 degrees and 1 atmospheric pressure. So we already discussed STP conditions. STP conditions. Here what are STP conditions? Volume 22.4 liters, Na molecules, 0 degrees Celsius and 1 atm, 1 atmospheric pressure. So these are the STP conditions. Okay. So these STP conditions is also known as NTP conditions. Okay. Remember this point. And here 22.4 liters have Na molecules. Na means Avogadro number of molecules. And 8.96 liters have how much molecules? So we have to do cross multiplication. Okay. So here 8.96 into Na by 22.4 liters. Okay. By here I am multiplying 100 and multiplying 10 because removing points. Okay. So here 0 gets cancelled and 224 4s are 224 1s are 224 4s are. Okay. So here 2 2s are 2 5s are. So 2 Na by 5 molecules will present in this gas molecule. Okay. So this is the answer. And I will explain again. Here they are asking to find the number of molecules in 8.96 liters. In 22.4 liters, Na molecules will present. And in 8.96 how much? So by cross multiplying 8.96 into Na by 22.4 into 10 into 100 for removing points. So 224 1s are 224 4s are. 0 gets cancelled and 2 table 2 times, 2 table 5 times. Okay. So the final answer is 2 Na by 5. Okay. So this is fifth sum. And today topic is completed. ఈ వీడియో కనుక మీకు నచ్చినట్లయితే ప్లీజ్ లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి.